Welcome to myprojectbazaar.com. Now we discuss about the product, a three-layered graph-based learning approach for remote sensing image retrieval. Now we discuss the abstract for the process. With the emergence of huge volume of higher resolution remote sensing images produced by all the sorts and the satellite images and the airborne sensors processes and analysis, these images require effective retrieval techniques to elevate the dramatic variations of the retrieval accuracies among the queries caused by the single image feature algorithm. We developed a novel graph-based algorithm learning for effective retrieving remote sensing images. The method utilizes the three-layer framework that integrates the strength of query expansions and future of the features, holistic and local features, etc. In the first layer, the two retrieval image sets are obtained by respectively using the retrieval method based on holistic and the local feature, and the top ranked and the common images from both of the top candidate list subsequently from the graph anchors. In the second layer, the graph anchors as an expansion query retrieve 6 image datasets from the image database using each individual feature. In the third layer, the images of the 6 image sets are evaluated for generating positive and negative data, and the simple MKL, that is the kernel learning, is applied to learn suitable query department fusion final image retrieval result. Extensive experiments were performed by the several datasets. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of several input images, that is the satellite images. Now I have plotted some of the example images in the flow diagram. After getting the input image from the dataset, the pre-processing is carried out. In this pre-processing step, there are two major modules is done. The first thing is the image resize and the second thing is the image filtering. Image resize is the process to resize the resolution of the input image into an various size. After the image resize, the image filtering is carried by using the Gaussian filter method. After finishing the pre-processing module, the feature extraction is carried out. In the feature extraction module, there are two major features are extracted from the satellite image. The first one is the shift and the second one is the gist. Then the feature points are concatenated into an test feature. After getting the test feature by using these two algorithms, the classification is carried out. In this classification step, we use the KNN classifier, that is the K nearest neighbor, is used to classify the type of input. After the classification, the retrieval is carried by three steps. The first step is first layer retrieval, and the second step is second layer retrieval, and the third step is the third layer retrieval. By the combination of these three retrieval process, the similar data from the database is retrieved. Now we discuss about the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. Now you can see the main.m file. Right click in that file and click the run to execute the code. Now the initial GUI window was opened. In that you can see the several menus and the several axes as well as the several tables. If you want to import an image from the database, then click the file and import image. Now you can see the folder QuickBird. Select the folder and select any one image from that folder, then click the button open. After clicking that button, the input image is shown in the axis 1 with the title input image. Then click the menu pre-processing. Now we have the two pre-processing steps. First one is the image resize and the second one is the noise filtering. Now I click the button image resize. Now the resized image is shown in the axis 2 with the title resized image. Then click the button noise filtering. After clicking the button noise filtering, the Gaussian filter checkbox is available. Now click the filtering and the filtered image is shown in the axis 2 with the title filtered image. Now the filter level that we applied is removal rate equal to 0.5. Now click the button compare. Now the comparison between the input resized and the filtered image is shown in the figure 1. Now click the feature extraction. We have two type of feature extraction. The first one is the shift feature extraction, that is the SIFT. Then the second one is the gist feature extraction, that is the GIST. Now I extract the shift feature from the image by clicking the shift feature extraction button. Now the shift feature is applied for the image and the respected feature which is extracted from the image is shown in the table 1. This is the overall features for the shift feature extraction method. Now click the gist feature extraction. After applying the gist feature extraction, the feature which is extracted by the gist algorithm is shown in the table 2. Now click the generate test feature. Now the two features are combined together form the test feature. Now click the button retrieval. Now the 4 buttons is enabled, that is the first level of retrieval, then the second level of retrieval and the third level of retrieval and also the performance. Now click the first level. Now the identified image is 8th image, then the second level of feature extraction is applied. Now the similar images in the databases are retrieved. Then the third level of retrieval is done. Now the most similar image is shown in the axis 1 and the relevant images are shown in the other axis. Now click the button performance estimation. Now click the button estimate. Now the estimated precision recall and the accuracy for the existing and the proposed is shown.